3-point fix practice problem 1. You are on course 0 to 5 per standard magnetic compass when you take the following bearings. Point Judith Light, 72 PSC. Block Island North Point Light, 116 PSC. Watch Hill Light at 306 PSC. What is your position? It gave us a heading and 3 bearings and asked us what our position is. So we need to take the deviation from our heading, apply it to all the bearings, and work them up to true so we can put them on the chart, right? All these bearings are in PSC, but to put those on the chart, they need to be in true. So we need to convert all these bearings on top, T, B, M, D, C. So I just put these in a grid so I can keep them all in check. Here we go. So here's our grid. And all of these bearings, here we have Point Judith Light 72. Point Judith Light 072 degrees PSC. That's why we're putting them in a compass. Block Island North Point Light 116 PSC, 116 degrees PSC. Watch Hill 306 degrees PSC. So these are the 3 bearings PSC they gave us. And it says, you are on course 25 per standard magnetic compass when we took these bearings. Our course gives us our deviation, right? We need to apply a deviation to these 3 bearings and a variation to these 3 bearings to get them up to true. So our heading was equal to 25 degrees PSC. This gives us a deviation. Our deviation for 25, it's about 30, 3 east, 3 degrees east. So that is what we apply to each one of these, the same deviation. This is interesting. This is where people usually mess up. They say, all right, 72. They go to their chart. 116, go to their chart. 306, go to their chart. That is not how you do it, because deviation is dependent on heading alone. So from the heading, you get a deviation. You apply the deviation to each of these 3 bearings. I forgot to label these at the top. Point Judith, okay. Block Island North Point Light. Block Island North Point Light. And Watch Hill Light. Watch Hill Light. Okay, here's 3 for the deviation. The variation is the same too for Block Island. 15 west, 15 west, 15 west. Now 72 plus 3 east minus 15 west is 60 degrees true. 116 plus 3 east minus 15 west is 104 degrees true. 306 plus 3 east minus 15 west is 294 degrees true. Now we have the true bearing of each of these. So we can put the true bearings on the chart, and that's what we'll do. Now, one of the most difficult parts of these problems are finding the points. So if you are having a hard time finding the points, the proper way is to go to the light list, find the index. Now we'll look up Point Judith Light in the index. Then to the right, here's all the numbers, right? So you go to Point Judith, find the number, go into the light list, locate that number, and it will give you the approximate latitude and longitude. That's the easiest way to find these. Okay, but I don't want to take up too much of your time, and I know where they are, so we'll just do this. Point Judith Light. Here's Point Judith. Right at the end is Point Judith Light. And it says a bearing of 60 true. So I come on the compass rose and say 60 true. I like to line my dividers up from the middle to 60 and then bump my parallel rules up next to it. Because you'll find out you need to be accurate with these problems, and this is the way I've found out to be most accurate. Okay, so now I'm at 60 true. I go up to Point Judith Light, you go right to the middle of the circle, and strike a line. Now we go to Block Island North Point Light, 104. Again, center of the compass rose to 104. Bump these up next to the dividers. Then here's Block Island. If you go to the North Point, here's the light. Flashes, 5 seconds, 58 feet tall. You can see it from 13 miles. Right to the center of that light. And mark a line. Now, Watch Hill Light, 294. I get 294 on my dividers, 294. Here's Watch Hill Light. Make sure it's on there. Watch Hill Light. Walk it up to Watch Hill Light. Draw a line. Okay, now I've got this small triangle. I go to the middle of this triangle, and it's long, right? But what I do is take the fattest angle and bisect that angle, and that is the middle of the triangle. If you cut each one of these 3 angles in half and drew lines, they'd all come together at the center. It's weird because the center is way to the left side of this, but that is the center. See how it cuts this angle in half, cuts this angle in half? There's the center. Now what I need to do is find the latitude and longitude of this center. You can do it with the parallel rules by lining them up north and south and then walking over to there and following it up and reading, right? And vice versa. You could do it this way. What I like to do is use my dividers. So let's find latitude first. This is the latitude scale, right? So I put one of the pointy ends of my dividers in the middle of that. And then I see where it crosses a line, a parallel, right? A line of latitude. And line it up here and say, okay, this is 4110, 4115, 4115.12, 4115.2 latitude, 4115.2 degrees, 0.2 minutes north. Let's see our longitude. So from this dot, see where it crosses. If you make an arc, you can tell. Okay, 71, 40, 1, 2, 3. 71, 43.0. Longitude. 71, 43.0 minutes west. Okay, let's see how these compare to our answers. Now I'm going to show you the method that I use to get my answers, because it just makes everything easier. A, B, C, and D. Now I look at these, I say, alright, answer A is latitude, 4114.9. This is 0.3 away from mine. And longitude, 7143.2. This is 0.2 away from mine. I just add these up, it equals 0.5. Now B, 4115.1. This one's 0.1 away. And 7144. This one is 1.0 away. So this one's 1.1 away. C. 4115.4 is 0.2. 0.2. And 7143.1. This is 0.1. This one's only 0.3 away. D. 4115.6. So this is 0.4 away. And 7142.8 is 0.2. So this one's 0.6 away. Okay, I would choose my closest answer, C. Let's see what the correct answer is here. C. The answer to 3-point fix practice problem 1 is C.